Okay, it's 1:05. I think we can get started now.
Okay, so everyone can hear me, whoever's on board.
I think everyone can hear. So I'll just give a quick introduction of Abdul. Of course, you know we've had 4 QMS seminars now, and this is the conclusion of that. So hello to you all, and thank you all for attending today's CREATE webinar, which is brought to you by the Center for Bioengineering and Biotechnology. This webinar is being recorded for the benefit of future CREATE trainings. I am Kenrick Vassell, Program Coordinator for CREATE, and as usual, it is my pleasure to be hosting today's proceedings. I will begin with a territorial acknowledgement. Much of our work at the University of Waterloo takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land promised to the six nations that includes 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within our Indigenous Initiatives Office. Today's webinar is the final chapter in our 4-part QMS webinar series and is presented by our special guest lecturer, Abdul Khalfan. The title of today's webinar is Failure Mode Effective Analysis. Mr. Khalfan is a quality management systems professional with over 30 years of experience in quality assurance, product development and validation, reliability engineering, and continuous improvement. Mr. Khalfan provides consulting services to medical device companies, helping them to establish and implement their quality management systems, ISO 9001:2015 and ISO 13485:2016 medical devices standard. Mr. Khalfan has worked with a range of companies, including NCR, AT&T, Flextronics, Bell Howell, ITT, First Data, Teledyne, Comdev, KA Imaging, just to name a few. On behalf of the CREATE program and the Center for Bioengineering and Biotechnology, thank you very much, Mr. Khalfan, for being here today.
My pleasure.
And with that, I'll turn the floor over to you.
Thank you very much, Henrik, for your generous introduction. Appreciate it very much. And as Henrik mentioned, this is the last of the 4 workshops during this semester at UW. What I like to say here is that this being the last session, however, the learning keeps on going. So first of all, I also want to thank for all the feedback that I received. Thank you for the generous, kind words that were used. Appreciate it. There was 7 feedback, and hopefully over time you'll expect some more. As I've said before, I'm a big fan of feedback because that's the only way I can improve and we can improve the seminar or the workshop going forward. So as usual, last feedback was that everything was great, but the workshop was too long, 2 hours. I totally agree with you, but unfortunately, I don't have the luxury of presenting the same subject over 2 or 3 different sessions. This is all I get is 2 hours. But then the good part is that this entire presentation is being recorded, and also you can see it on your website, on YouTube. So if you don't have the time example in this one, stay as much as you can, and then what you can do is maybe come back later and pick up where you left off. That's the best suggestion I have. So thank you again. So we are going to move on with failure mode effective analysis. So those are the topics that we are going to go through. I give you just about 30 seconds or so just to go through it, so you have some inkling as to how we are going to be moving. You can see there are quite a few topics, but we will move on at a pace that we can accommodate within the time frame. All right, so what is failure mode effective analysis? This is just a preamble, just to give you a break-in so we can break, you can wet our feet, and then we have more information as we go into the next slide. So it's a very famous tool, and I'm sure some of you folks have already heard of it. It's a acronym. Its acronym is FMEA, and that's failure mode effective analysis. Basically, it is an excellent tool for a team of design, manufacturing, industrial, test, service, engineers, quality, maintenance personnel, program managers, and the C-suite, which is CEOs, COO, Chief Operating Officers, financial controllers at large, and to address, and why? So that you can address the issues and ideas of improvements regarding your products and your devices in an objective manner. And that's the key, in an objective manner. Last time we talked about maturity gate, that was also based on objectivity and not subjectivity, but there had to be a consensus. This one is no different. It has to be no different from the sense that it has to be based upon objectivity and not subjectivity. And also that it makes business sense. That's very important, making business sense. So there are all kinds of improvements, addressing issues that are there. However, we need to be cognizant of the fact that are we also taking into consideration the business sense of it. So we will get into that, park it at the back of your mind. You will see what I'm trying to say here, objectively come to a conclusion which has also business sense in it. And that's very important because dollars and cents are also important. All right. One of the salient features is that it can be put into effect or it can be practiced at any given point in time within the product life cycle. Now, bear with me and you will see how. Unlike the maturity grid, in failure mode effective analysis can be run at any point in time during the product development cycle and also after the product has been gone to the market and it is being used by the customers. So it is not only during the development cycle that you go through the prototype, the verification, the validation, and what have you, but you can use it at any given point in time that you find it necessary that we should come up with some solution. Now, again, it is objectively based, and the key thing to remember here is that there is a risk priority number. Its acronym is RPN. RPN takes into consideration a pragmatic approach to make a conscious and a calculated business decision. So you see that I've already used the business decision, business sense a few times here, but we will see how we can coordinate both together to come up with a viable and a profitable solution for the issue or the improvement idea that we have in mind. Once again, the key difference between FMEA and maturity grid risk level concept that we discussed last time, for those who were present in the workshop, is that it can be practiced or applied at any given point in time during the entire product life cycle. Remember, the product life cycle does not end after the product or the device has been designed and manufactured and released. There are two other stages of product life. That is the end of manufacturing and end of life. End of manufacturing, when the company decides that it's not going to move forward with marketing that product anymore, and it gives a notice to the manufacturer that after maybe 5,000 units, we will not manufacture anymore. And then, of course, it's the end of life where you need to take care of some of the customers who may want your service, and it is also known as the twilight zone, and where final parts are being bought out and other processes are put in place so you don't leave the customers hanging. So basically, it's not just the development cycle, but there are two other cycles that we should also be careful of. So I think that's the preamble, and then let's move forward. Sorry about that. All right, so I'm going to see. It's there. I apologize. My screen is acting up. Okay, so let's look at what is product liability, because this is important to understand that why are we using this tool. There are two quotes here. What you see is from a very famous author, a very um, uh, well-known author, D.H. Mathis. He's written over 70 papers. He's the author of several books, and he's well known for failure mode effective analysis. So according to the quote, the term product liability often stands for a variety of meanings. However, the term in law is defined as the liability of a seller or a manufacturer for damages caused by its allegedly defective product. Product liability action can be based on a number of legal theories. This is important, including negligence, strict liability, fraud, misinterpretation, warranty, and so on. So if you are a founder or a co-founder or you are a top management person, those are the things that you have to always be careful about. Product liability action can be based on a number of legal theories, including negligence, strict liability, fraud, misinterpretation, warranty, and so on. To more fully understand the legal concepts, one must familiarize oneself with some of the basic theories. That's one important quote that I got from the book. The second one is theories of recovery. Although several legal theories may be used in a product liability action, the three most commonly used are negligence, warranty, and strict liability in tort. Now, I'm not a lawyer, but here's the meaning of tort that I could find from Merriam-Webster's dictionary and thesaurus. It's a wrongful act that does not involve a breach of contract and for which the injured party can recover damages in a civil action. Example, if you are working somewhere and the floor was slippery or something and you slipped, you can sue the company or the owner whereby you broke your leg or your arm or you hurt yourself. But there were no contractual breaches in that effect. Of course, another meaning is a wrongful act or a violation of a right. So there are torts in many instances. And all these two of the quotation that I just read to you, which I'm sure you can do, are very important to keep in mind. All right. So, okay. So looks like it wasn't at me, but yeah, it's frozen at me.
Hi, Abdul. Maybe we can close PowerPoint and restart it. Maybe that will
Yeah,
help.
I think so. Okay, I'm going to take this approach here, and I'll take one at a time like that. So can everyone still see what's there clearly?
Please just respond in the chat if you can see clearly the slide.
Yeah, so if I go in the screen mode, the forward slide other way, then
They can see Abdul.
So it's fine. All right, sorry about that, folks. I tried, but then it's not going to work. All right, so let's keep on moving forward. What are the pressures in everyday life, and what are the overall perceptions of risk? Well, first of all, there is always safety risk. There is market pressure that we need the product really soon, management emphasis, development of technical risk, public liability, customer requirements, warranty and service costs, legal and statutory requirements, and there are so many others that we couldn't fit in on this page. So we have to remember that there are pressures. So as you as a design engineer, development engineer, a top management person, or even at any other level in a company, we all have pressures and we all have to deal with them. And the best way to, and the whole idea is to minimize the risk. How do we minimize the risk at all times? Okay? And that's the key factor. So what is FMEA? FMEA is a systemized and structured activities. These are activities that will recognize and evaluate the potential for failure of a system, product, process, service. So hang on with those terms there, system, product, process, service, because we will be going into each one of them to the different types of FMEA. The effects, what are the effects of these failures? How high the risk is? What is the severity? What is the occurrence? And how do we detect? What is the frequency of detecting these failures? And based upon the risk, then we identify the actions that are designed to eliminate or reduce the chance of a potential failure occurring. The whole idea is how do we minimize the risk? And we can minimize the risk in several ways, which we will go through some of the practicalities in the next few slides. We also document, the important thing is that all of these activities that we jot down, how to minimize the risk, they are recorded, they are documented, so that maybe in the future time, if you need to know what happened where and what happened at sixth bar of the symphony or any point in time, we can go back and pick up on it. The key consideration here is that it should be complementary to defining what the design must do to satisfy the customer. So at the outset, when we are in the development mode, that's when the risk minimization of risk level starts right from scratch. And how do we move forward to come up with a product and a device that will be safe, that will be meaningful, that will add value, and it will minimize the risk from all angles that we just talked briefly about in the previous slide. All right. A brief history of FMEA is in the 1960s, the aerospace industry was facing, well, they still face issues and problems, and we've seen it all along, how important it is. The aerospace industry came up with FMEA. Then it was in 1974, US Navy developed MIL Standard 1629. These are sampling plans, basically, and they were based on failure mode effective analysis. Then in the late 70s, the automotive companies wanted to improve their vehicles. They wanted to improve the cars and minimize the liability costs, because if the brakes failed, if the steering didn't work properly, if the shocks were not right, then the companies were being sued left, right, and center, and they're still being sued, and they're still working at it. But relatively speaking, we have come a long way, and the risks have been minimized, but they are still working on it, and relatively, again speaking, we are driving safer cars. Then TS 16949, which is technical specifications, and the IATF is the International Automotive Technical Federation, or the force, who have established the quality system requirements, just like the ISO 9001 and ISO 13480. So that's the background to FMEA. Now, I'm just bringing this slide up from the previous workshop we had, where we talked about the maturity grid risk level concept. If you recall, for those who were present, that there are several tools. Now, FMEA maturity grid is not the only, they are not the only tools. There are risk plots, there is mean time between failures, service calls, checklists. So what I'm trying to emphasize is, don't bear in your mind that we have only two tools to work with: maturity grid and failure mode effective analysis. And there are several more that maybe you may be aware of and I'm not aware of, but there are tools to work with. That chart that I still like to talk about very quickly is that that's a chart that my years of statistical analysis and reporting what's eating our lunch. It was always true, whether we were in the design mode, whether we were in the marketing mode, whether we were in the manufacturing mode, in the service mode, approximately 45% of the failures were because of the design. So it becomes incumbent upon the design engineers and the company where the product has been designed to minimize the risk, to bring the service call rate down, to look into the safety aspects. It is so very crucial. Then 25% of the failures were because of manufacturing issues, and 10% because of service, then 10% for parts, of operators, 10%. Now, these are approximate numbers, give and take maybe 5% up or down, but those are the numbers that are very clear, and I can guarantee you that if you were to go to your desk and you were to move forward with the development cycle, or after the product has been released, and you did a Pareto analysis of all the failures that come into effect that you look after, your analysis will be no different than what you see in that chart. So I'm emphasizing that coming up with, by minimizing the risk and the failures not occurring, is very important. The challenge for all of us is, can we bring this 45% down? Can we bring the 25% down? Can we bring the service 10%? Any which way we can minimize the risk is important. All right, as I said, there are different types of FMEA. There are basically 4 types of FMEA. The system FMEA, sometimes it is also known as concept FMEA. Well, the system can be a device plus some other components attached to it. So the definition of a system in the last workshop was given. If someone was not present, I encourage you to go back to the presentation that was made last time, and over there the system definition was emphasized. It is used to analyze systems and subsystems in the early concept and design stage. It focuses on potential failure modes between the functions of the system caused by system deficiencies. Now, within the system, so you test, example, you test the printer, the 2 screens you have in front of you, the keyboard, the mouse. So that's in totality is a system, but within the system, you may have keyboard or a printer or a laptop that may not be functioning. So it's a system, the subsystems, and all these are at risk, and we need to minimize the risk. So then you have the design FMEA, which is used to analyze products before they are released to manufacturing. It's very important. We will go through some examples. It focuses on failure modes caused by design deficiencies. Then you have the process FMEA. Now remember, all work is process. So process FMEA is not only related by saying it's the process, design is a process, service is a process. But specifically what is talking about here is process FMEA is mainly used to analyze manufacturing and assembly processes. Remember, there are maybe depending on the complexity of the device or the product that is being built or manufactured, there can be 10, 20, 30 different assembly processes. And each one, if there are deficiencies, then you look at each one of these processes to weed out what the failures are and how do you minimize the risk. Then you have the service FMEA, used to analyze services before they reach the customer. So if you have a service that you are designing, what your process is going to look for the new product that you're designing, you need to take into account several factors: the environment, the customer, the travel distance, the contingency plans. If you cannot fix it, can you replace it? There are so many other elements that are involved within the service sector. So we will look at some of one example. I'm pretty sure we have the very first example is based on the service FMEA. Okay, moving forward. So we talked about the risk priority number. This is the key. The risk priority number is what we are after. The output of the FMEA is a result known as RPN, risk priority number. The RPN is calculated based on information the team provides regarding the frequency of the potential failure modes, the severity of its effects, the current ability of the process to detect the failures before reaching the customer. RPN are not universal or fixed. I have highlighted that because as we go into other slides, I have delivered this workshop several times, and there are key common sort of misconceptions that the audience has, because when it comes to effects, causes, and controls, and the scales that we develop, what I'm going to present are just going to be examples. You can come up with your own severity, occurrence, detection, scaling as scaling that is necessary. So just bear in mind, RPN are not universal or fixed, but you can tune it to tailor it to your requirement. And how we will see that. Okay, this is again I've highlighted. It's an example. The example I have here is a rating from 10 to 1. 10 being the very dangerous, it's hazardous, and 1 being that it probably doesn't have much effect. Now, mind you, you can reverse this. You can reverse the effect of severity by saying 1 is most hazardous and 10 is the least hazardous. Or you can say 5 is the most hazardous and the scale is from 1 to 5. It's not from 1 to 10. So please bear in mind, this is just an example that I'm presenting. You are at your own discretion. You can come up with your own severity scale. And then we'll go into the occurrence scale. The occurrence scale is no different. It has to go hand in hand with the scaling that you come up for severity, occurrence, and detection. So over here, You have hazardous without warning, hazardous with warning, loss of primary function, reduced primary function performance, loss of secondary function, reduced secondary function, minor defect noticed by some customers and by most customers, and minor defect noticed by discriminating customers. Please don't take that word discriminating as discrimination. It is discriminating customers who are very sensitive and who cannot bear a scratch on that product, and that's me. So, and maybe there is no effect on it. You know, failure is unlikely. So bear in mind, this is an example rating scale. It is not something casted in stone, or Abdul said that the rating 10 is the highest and 1 is the lowest. Don't worry about Abdul. You can come up with your own. So customizing the scales. So we look at each of the scales. Severity scale, you see criteria: a failure could injure a customer or employee, be illegal. Remember, we talked about tort, render product or service unfit for use, cause extreme customer dissatisfaction. So you go through that list. I'll give you a couple of minutes, go through the list, and we'll come back. So as I said, folks, the important note on the top is these scales are examples only. A company can, at their discretion, construct their own as it best suits their case or the cases of the issues. So moving forward, just bear in mind there are 3 levels of elements that we take into account to calculate the risk priority number. Severity times occurrence times detection will give you the RPN number. Okay, so I said, here's a quiz. The quiz is simple. We will do it together. So again, I highlighted example only. On the top, I have severity scale. Over here, I have severity scale. What is rating? The unnoticed and no effect. 10 is injure a customer or employee. Occurrences 10 more than once per day. 1 is once or less than. This is mainly if you're taking into account some parts. Detection, defect caused by failure is not detectable, and then defects is obvious and can be kept from affecting the customer. So let's take the first example. The first example is that we will show you how to calculate the RPN. Just bear with me right now for the sake of clarification. So severity was 1, which means be unnoticed and not affect the performance. Occurrence was 1. So once, less than 2 per billion, or however you want to scale it. And then the detection was 1. The detection was defect is obvious and can be kept from affecting the customer. So it is obvious, but it is not something that the customer will be down. Now that's an ideal situation, so there is no action necessary. So if we were to do FMEA and we came up with that number RPN, then it doesn't require any action. It's an ideal situation. Now the next one is 1, 1, and 10. So the severity is the unnoticed. The occurrence is more than once per day. It's getting a little annoying. And the detection is 1. The detection is defect is obvious and be kept from affecting the customer. It's a low remote possibility, and so there is no action that the team decides no action. Now, it's your prerogative. If you still feel that no, although it's low remote possibility, we have enough funds, so let's attack this issue and get it out of the way. We want 100% customer satisfaction. We cannot bear it, so we're going to do it. Nothing will stop you, so the action that you see there can be your own action that your team comes up with. I want to emphasize that FMEA is not done in isolation. You cannot do it by yourself. Well, you can if you want to, but it has no meaning if the team is not there and is not aware why something is being done. Now we take the next example, which is 10-1-1, and the RPN is 10. So there is a concern. Do some enhanced control. Put some more controls and see how you can manage to come up with less than 10. Then the next one is 10-1-10. That's RPN is 100. Now, there is a concern, and the priority is priority control. Then the next one, 1-10-1, is a 10. It's a low concern. So the 10 occurrence, it happens quite a few more than once, but it is annoying. But the RPN is 10, so it's a low concern. Then you have 1-10-10. Your RPN is 100. It is still a low concern. Why? The severity is not much. Now this is something that I came up with, and I was developing the workshop. This is where I came up with, okay, so if severity is important. So severity is really, really important when a failure is occurring. Is it a rest severity or how is it? Then there is the occurrence is happening more than once, and the detection, it's not detectable. It's not detectable. So I say, okay, it's a low concern. Then we have 10-10-1, 100. Now it's a major concern. Why? Because the severity is high. Maybe there's a safety issue. Maybe there's a regulatory issue. Maybe there is something that the customer cannot bear. Occurrence is 10. It's happening more than once. And the detection is not keeping is obvious and can be kept from, I think there may be a word missing here. It cannot be kept from affecting the customer. So this becomes a major concern. Constitute to implement controls for plus improvement. Then of course you have 10-10-10, that's 1,000. It's big trouble. Now we need some emergency action. So bear with me, let's go to the next slide and we will see if all of these come into effect. This is a typical worksheet template. On the left-hand side, you see all what the problem is. The problem is, you see system, is it design, is it process, or is it the service function? Then what is the potential failure mode? What are the potential effects of failure? Severity scale 1 to 10. You may have 1 to 5. You may have 1 to 3. It's up to you. You may have 1 to 20. Who knows? I mean, depending on the device and the product and the issue that you're working on. Then the potential causes of failure. What are the potential causes? Do we know what the root cause is? Now, remember, we are not talking about root cause here. However, we do want to know what the root cause is, but we want to know what are the potential causes of the failure. The occurrence, again, scale is 1 to 10. You can have your own scale, but what are the current controls? Are there any current controls? And you will see in the next slide, I believe, where we talk about an example. What is the detection? So what is the total RPM that you come up with? So after going through severity, occurrence, and detection, we multiply the severity by the occurrence and multiply that by detection, and we will get a number. Now, that's the first section. You can call it the raw section. It is raw because we have a problem, we know what the severity is, the occurrences, and the detection is. Now we need a solution. So the next section, as you can see, is actions and results. So the actions are recommended actions. Now, as I said, the team is important. If there are 5 in the team or 10 in the team, every one of them may come up with one suggestion, a solution. And we have to respect each one of them. We cannot say, oh, we are not going to look at that because this is ridiculous or whatever. No, we are going to look at every single suggestion and the recommended action that is given. We do not overlook or take it for granted that we cannot look into it because it doesn't make sense. Even if it doesn't make sense, put it down because we need to record it. And what is the action taken? Then we have revised severity. So first time your severity may be 10. With this action, your severity may be reduced to 5. Who knows? Or it may be 10. It may make no difference. So at the end of the day, you will have a revised risk priority. So say the RPN here was 100. And with the actions to improve it, your revised risk RPN can be 50, can be 75, can be 80, can be 60. So based on that number, objectively, then the team can decide which. So another solution may be that the risk priority number goes down to 25. So between the two solutions, obviously 25, bringing the risk down to 25 makes more sense. Now, hold on to your thoughts. I talked about business case. It may be that the RPN, which is 25, is going to cost a whole bunch of money. And the revised risk priority number is 50. And the business case has to decide, the team has to decide, this is not going to cost as much money. So given the budget that you have, given the time frame that you have, given the scope that you have, does it make sense to go with risk priority number 50? Or does it make sense to go with risk priority number 25? This is why I will keep on emphasizing that it is an objective tool, but you've got to complement it with a business decision also. And it has to be a team decision. Now, that was a plain template. So over here, it's a little bit more pictorial. That's your key system process service input. What is the potential failure mode? In what ways does the key input go wrong? Then potential failure effects. What is the impact on the key output variables? Customer requirements or internal requirements. Then how severe is the effect to the customer? How bad? That is your severity. What are the potential causes? What are the key causes the key input go wrong? Then how often? That's your occurrence. Then what are the existing controls? So what is it that you have in place today that you are trying to control the issue or trying to control the idea of improvement? So how can these be found or prevented? Then you have detection, how well can you detect cause of failure mode? And then risk priority number based on the improvement or the actions that have been recommended. And then you come up with an RPN number. So that's a little bit more colorful chart there that can help you better understand what those different columns are. Severity, occurrence, detection, you have a RPN number, then you have actions recommended, and the actions recommended follow the same suite, like here, revised severity, revised occurrence, revised detection, revised risk priority number. Okay. Now, here's an example. Look at it from a process and a service point of view. The example is that the answer phone potential failure mode is answer on or after fifth ring or before the fifth ring. So potential effects of failure: customer hangs up, plus customer becomes disgruntled, plus loss of current sales, plus loss of future sales, plus interruptions to flow of pizza making process. So this is a pizza making facility. And if you don't answer the phone on or after the fifth ring, immediately after the fifth ring, you're going to lose the customer, you're going to lose business, you are going to lose future sales. And you are in the pizza making business, you need the $9.99 for a large pizza, hopefully with 3 items. Oh, that makes me feel hungry. It's getting lunchtime. Okay. All right. Potential causes of failure. Can't hear the phone. What is the occurrence? It's a 3. All right. What are the current controls? Ringer set to loud, plus music in seating area not to exceed a 4. Setting plus staff training. Detection is 5. The risk priority number is 105. So what are the recommended actions? Remove seating area music from the music from somewhere, from that seating area. Responsibility and target completion date. So that's the date that the action taken is saying that you can do this by removing ringer set to loud plus music and seating area not to exceed a 4, setting plus staff training. You do all those controls that you want to put in place or do better than that. But the important thing is you remove the seating area music from order area. And that will bring down your RPN to 42. Now it's the same problem. Another one, potential causes. What are the potential causes? That the phone too far to reach in time. That's a pretty practical one, that it may be placed so far that it's reached in time. Take-off spot for phone plus end of shift area, cleaning up requirement, and you go through the severity detection, and the risk priority number over here is 392. You buy, so what is the recommended action here? That you buy a wireless phone handset system, or, who's the responsible person? Then the action taken is that it's too expensive, deferred to next quarter's budget. So you can't do that, and your risk priority number doesn't change. So you say, all right, it's good you brought up that suggestion, but we don't think we're going to go with it. As I said, the money is too much. Buy a wireless phone headset system is going to cost extra money. We have a Rogers or a Bell line, and we have a landline, and the phone comes in, and that should be good enough for now. And the staff tied up in work that cannot be interrupted. So a suggestion was have one available staff member always assigned to phone duty only. Now that's going to be a tough one. So the risk prior occurrence is no different, is 3 here. Now risk priority number becomes 105. You have severity 7, the occurrence is 5, and the detection is 3. Now what do you see? Over here, they have no action. They're not going to hire another person. That's out of the question, and the risk priority number is 105. So what are we going to go with? We're going to go with 42. And that can be, you just remove the seating area music from order area. You segregate, you separate them, and then from 105, you will improve to 42. Now, there was no cost involved. It was practical, and you move forward with it. So that's an example of process or service. Okay, let's look at another one. Now, this is a design or product. Okay, this is automated wafer detection, defect detection. So as you know, the soldering wave, automated wafer detection and what have you. There are monitors everywhere. So here's a situation, subsystem. Remember we said the system or a subsystem, module and function. Over here we are looking at 16-inch color monitor, loss of video, and the severity is 6, it's pretty high. 1 CRT component failure, potential cause, occurrence twice, maybe depending on the frequency you want to look at. And then the detection is 1. So one being, let's say, one being low, detection is low. The first recommendation was recommend the 14-inch monitor be used as a backup to provide the operator an interface. However, graphical data representation will become degraded due to the loss of high resolution. High resolution is very important. High resolution in automated wafer defect detection. So John Doe electrical and dairy software will evaluate the proposed configuration by this date. Actions taken, not accepted by the reliability review team. See report number. Remember, we said that we need to document everything. We need to document what happened when and why it happened and why it was rejected. So the RPN number calculated was 12 to start with, and it didn't change, it remains 10. Oh, sorry, 12. Now here's a smart one, and I like this. Loss of video, same problem. Power supply failure. Potential cause is a power supply failure. Occurrence, it occurs quite a bit. It's like between 1 and 10, so it's fairly up there. And current controls, there are none. So the recommendation was you multiplex the 2 CRT power supplies so that power failures can almost be eliminated. So you piggyback, it's like having a backup. So you piggyback on the 2 power supplies for the CRTs, and then you will have less number of 16-inch color monitor going fail. So then due to cost and time, this option has been accepted by the reliability review team, and engineering change will occur. I hope all you folks understand ECR and ECN process, engineering change request and engineering change notice. They're very key important processes. That's not the subject for this workshop, but please see if you can find out what ECR and ECN mean as far as processes are concerned in the development process, even after that. Long story short, with this suggestion, the revised severity occurrence detection brought you down to 6. So from 12, from 150, the power supply failure was rated as more likely than the CRT component failure. And the RPN here was 150, and it brings it down to 6. So what's the obvious conclusion? We're going to go with this one. We're going to go with it. I'm sure there were others that were there. I'm just showing you as an example. All right. So now it's 1:59. Why don't we take a short pause for a cause? Say 10 minutes, or we come back, or 11 minutes. We come back at 10 after 1, or sorry, 10 after 2, and we will pick it up from there. How's that? Okay? So we'll see you after 10 after 1. Or 10 after 2, sorry, where am I?
Okay, thanks for part 1, Abdul. So we'll return at 2:10
Yep.
for the second half of the presentation.
Thank you. Water. Thank you, Henry.
Hi, Abdul.
Right, back.
So it's 2:09. I guess we can give them extra minutes.
Yeah. There's not much left now, so that's the good news. It's not going to take long.
Yeah, we did go a bit long last time with the Q&A, so it's a little bit shorter this time.
Yep, this will be. I think I have two main slides to talk about, and they show there. Yeah, maybe three, and then we can take the Q&A. We will be done before.
Okay, well, it's 2:10 now, so I think we can resume.
Yeah, you have enough there, or only two people come back?
Well, nobody logged out, so I'm not sure.
All right.
You're back at your computers, but we did tell them 2:10, so I trust that they're back.
Okay, so we move forward.
Yes.
All right, folks, welcome back. So I'm going to share with you a practical exercise, a practical work that I did when I was at NCR with a team of engineers, manufacturing engineers, design engineers, supply, service engineers. And the picture that you see, this was check processing machines. So you see the check here. So what these machines did was that when you write the check and it goes to the bank, you have the check number, the branch number, the account number, the amount. They are all printed. Like this machine, if it's a blank check, it will print all of the information in the bottom of the check, which is the bank, the branch number, the transit number, the account number, and the amount, and whatever information is needed, they were encoded. They were encoded at the bottom of the check. This machine you see here was a flagship machine. This was a bread and butter. There were over 25,000 of these machines worldwide. And having said that, I will just focus here. This part here was the encoder. This is the encoder. So the check rolls through the transport, it goes through the track, it comes here, and if we open this cover, there's an encoder there's a special ribbon, and it will encode the check numbers down here. Now, we were having problems in the sense that we could improve the mean time between failure. The mean time between failure was that was the criteria that was established for it. So we went to work. Now, I traveled quite a bit to get first-hand information from the customers as to what is really eating our lunch, what is really going on that it is performing above average mean time between failure. And it's costing a lot of money. Every single service call was, in those days, in the 90s, was $160 US, every single service call. So over 25,000 machines, if you calculate $160 US at that time, maybe it was 10 cents per dollar, but it was a lot of money, and it was eating our lunch. I mean, it was just taking away our profitability. So we said, all right, we came up with some of the top-notch failures that we could find. So you see that encoder, there's a hammer assembly and excessive encoding failures. My analysis with the Maybe I visited 10 different sites, different combinations, and the end result was that there were excessive amount of encoding failures. Now, one of the assessment was, so the severity was high, but medium there it says 5. This is how the team said, okay, so the severity we're going to say is 5. We're going to say it's unreliable adjustment of the eccentrics A and B, and the adjustment drifts away from the specific tolerances over time. I will bring this so that you folks can read. Okay, I will take my chances because there are 2 more slides. So I hope you can see it much better now. So if you see the first analysis, potential failure mode, excessive failures, severity, they said it's a 5. Then the occurrence, it happens quite a bit, that's a 7. So this, what we were looking at is we were scaling it from 10 to 10 being severe and 1 being not as severe. And we had drawn up the scale, 1 to 10, 1 to 10, 1 to 10. Now, so the design engineering improved the locking device for holding the A and recommended action. This is what we said. Okay, let the design engineers come in and improve the locking of eccentric A and eccentric B so it remains firm and it will not drift away. So there was a person, engineer Dave Norris, January 4th. I put 2014, but this was much before that. Actions taken, there were none. Referred to engineering report. The engineering said, we don't think we can do it, but it's not right to do this. We need to come up with something better. Encoder hammer assembly. Okay, here we go. So my analysis showed in the field that difficult to adjust while the assembly is in the machine. If removed for cleaning or replacement, major readjustment is required. Once removed, the service engineer has to revisit few extra times to readjust the eccentrics. Goes back to the first one. The adjustment drifts away. It specifies tolerances over time based upon its usage. Customer detects the failure and places a call for the field engineer to arrive at site and fix the problem. Field engineers are trained at the Technical Education Center. So the severity, the RPN number was a 35. So one of the suggestions was redesign the hammer assembly with robust adjustment or stuff. That's easy to say, but it would cost a lot of money. It would cost a lot of time. Refer to engineering report. Redesign not cost effective, as you can see. So the RPN remains the same. The encoder assembly, excessive encoding failures. Foreign objects such as paper clips, pins, staples, thus penetrating encoder assembly, vital parts area creating flight time errors, thus hindering proper functioning and suggested for compensation. The foreign objects cling to the electromagnetic plates of the hammer assembly. So there was some magnetism in the hammer assembly that attracted these foreign our checks, when you look at them, some have staples on it, some have clips on it when you are in the processing center, and that would be attracted and that would put the encoder assembly haywire. It would go haywire and the adjustment is out. So it says none, no prevention right now. The current controls, there is nothing to prevent for these outside objects or external objects or foreign objects to enter the encoder area. So the RPN, we had a 5, 7, and 1. RPN was 35. So now, what was recommended? Design a cover or a provision of a magnet in the base of the machine to pull or attract all paper clip staples. Not a bad idea, but you need a very strong magnet to attract the foreign objects. Engineering designed a metal cover. Now, what I told them was that, look, instead of the magnet, we put a little cover where the hammer is, just enough for the hammer arm to go back and forth to encode, but do not put the hammer underneath, have this little piece. This costs no more than 5 cents, no more. So you don't have to come up with the most complicated idea that will solve the problem. You can come up with the most practical one that is easy to design, that is easy to put, easy to test, and you solve the problem. So they designed the cover, it was snugly fitted, then we tested the machines, the sample size, maybe 10 machines, or actually we put the hammer on test beds. There were like more than 10 or 20 of them on test beds, and they kept on working as if they are working in a machine. And it worked fine. It took away the problem, and the RPN was reduced to 25, as you can see there, for the hammer, and we saved about $250,000 per year in service call just for that particular service call. Now, there were other failures that we addressed, but I'm showing you an example of the encoder assembly. So in those days, we saved $250,000 per year, plus the customer satisfaction. So the customer satisfaction from being like 50 went up to 80. Like, they were 80% more satisfied. They still needed some more. I'm just throwing a number out there. But this was huge. This was huge. And it was a 5 cents cover that was designed and put into the machines at the time of manufacturing. It was also a spare part if needed. And maybe it was less than 5 cents. It was 5 cents to start with, but it may be even less. So the idea is we had an RPN of 35. We reduced it to 25. It was cost effective. Now you see, there are other cases. What happens is, so I'm going to give you the business case, right? So there were other situations where it could have been improved. But the business case being the product, sometimes the product life is maybe 5 years, maybe 7 years, maybe 3 years. And if you are at the end, of your product life cycle, you have only 1 more year. The business case would be, do you really want to spend $100,000 to design a new hammer assembly or an encoder? Or do you want to go with the 5 cents design that will take care of it? So you may have even a better design in mind. But what makes sense from business? And sometimes the business case may be, not in this case, but the business case may be that, look, we've seen all, we've heard all, we have documented everything, but the product is not going to be under service after this year or after 6 months. Do we need to spend this much money to improve? This problem I'm going to talk to you is not listed here, but I will talk to you. Every year, a general manager came in with engineers and quality engineers and what have you, and said, one year he came and he said, we don't have a budget. I don't have anything to give to you. Go back to your room or go back to your cubbyhole, cubicle, and come up with some ideas that how can we reduce the service call rate. So in this case, we came up with an idea. We don't have the money. In those days, remember, in the 90s, the operator manual was hardly known at that time. Now, of course, even if you buy a small little gizmo, there'll be something written up for safety or operation, or some figures will be given. But in the late 80s and the 90s, that type of a thing was unheard. I mean, they were, but it wasn't common. So we came up that we are going to come up with the operator manual, how to handle your machine when you have some issues, some basic issues. So we came up with a manual, and we reduced the service call rate by half, like half, 0.5. we improved, let me put it this way, we improved the service call rate by 0.5. So the point of the matter I'm talking about business cases, your RPN can say something which is great. We need to know your improvement ideas are there, but then you need to have a balance. Does it make sense? Does it make sense to spend $20,000 when the machine is not going to be there or not going to be serviced after, and the time, the resources? It's not only the money, it's the time and the resources too. So it has to make, so if the design engineers are busy designing the next product that is going to be out there, you don't have the resources, or you're not going to go and hire another engineer to come and do this work. So I'm going back to the first or the second or the third slide, where we talk about the business case has to be complemented with the RPN, and then you make the decision. So this was there. I'll talk about another problem here, main PCB board motherboard. This was a new product, new model of it, and it went out, and immediately we started getting calls that the machine is in smokes. You plug it in and the machine smokes. Not every single machine, but there were serious number of calls that would come in that would say, hey, you plug the machine in, it's not plug and play, it's plug and pray. So this is what is happening. So I was sent down to Houston. That's where one of the problem was. I went down to Houston, I plugged the machine in, and poof, it went into smoke. I said, holy mackerel, shut the circuit breaker, make sure nobody's around, and this is a hazard area, because you remember we talked about liability, warranty, the legal actions, it all comes into play. This was serious matter. So I dismantled the whole machine and I looked at it. The motherboard was a one big motherboard that had soldering bits that were touching the base of the machine which was conductive. So there was a short being created. When I looked at the motherboard, the stems that were coming out were long. They were not cut properly. So what did we do? So the first thing we did, we put a non-conductive cardboard or a piece of paper that shielded the long. At that time, it was known as PCB hole-through soldering. They were not big soldering machines at that time. Then we improved the base. It was made of zinc, and we reduced it. So the severity from RPN of 60 went down to 1. So immediately we took care of it. But the thing is that we had to brainstorm. We had to troubleshoot to see what was going on. So that's one. Now, this here, you may not see it properly. Keyboard stem. I'm going to take you back. Here. You see, this stem is a zero key. The zero key is used the most. It is a long, elongated key. It had one plastic inside, one plastic stem that was holding. So this was the key that used to get damaged the most. The damage being the stem used to break. So what did we do? So we went to action with FMEA, and we said, okay, look at different things that are happening. And we went through several, and one of the things, so the RPN was 49. So one of the things I suggested was put 2 rubber stems on either side of the machine. So the travel, when you hit the zero key, the travel is not all the way down, because when it goes all the way down, it bounces with the base of the keyboard, and it has more pressure, it has more travel time, and then it breaks very quickly. So simple as 2 cents, 2 pieces of rubber foam, right underneath it, precisely measured and sliced, so that when the key stem travels down, it's not going to break the stem as often. So there was a business decision. Are we going to? No, we could have designed a total different key. We could have put two stems in it to balance it out. We could have done several other things. But this was something very obvious. You don't need to be a rocket scientist to come up with the solutions that will make more business sense. Everyone was happy. So that is what I'm trying to bring at. That although you haven't seen many other solutions that were given here, main PCB board, keyboard assembly, there were several others, but doing the FMEA analysis, everyone had the right to come up with their ideas, and we respected everyone, and we thanked everyone, and we came to the conclusion as a team that this is the most cost-effective way based on the FMEA that we have done. Now, what I've shared with you here is true practical benefit of a design FMEA, that a real life example that we conducted. So hopefully that sheds some light on it, the benefit of the FMEA. Again, please, 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 the severity scale, you define it. The occurrence scale, you define it. The detection scale, you define it. This is something that we went with, that we did. And there was another one too, I haven't gotten here, that was quite recently. The company was trying to save $1 on the cost of a speaker or a secure payment transaction system, $1. And guess what? We went to FMEA and we came up with some great ideas to improve the packaging. The packaging could save us $1. And why they wanted to save $1 was because they wanted to buy a better processor, a better chip, a better IC chip that they could put inside the machine or inside the device or the gizmo, and you put it in there and it would give better results, better sound, better stability, better reliability, better serviceability. So they wanted to save $1 to install or to buy or procure a better processing chip so that they could get the benefit out of it. So we redesigned, not going to the drawing boards, but it was very easy, not easy, sorry. Actually, we went through a long and lengthy time of spending our time on coming up with failure analysis or failure mode effective analysis. And finally, we did come up with some packaging improvement that would save $1 at the same time. Bear in mind, at the same time, we made sure that the packaging was as safe as it was when they first designed it, and that was accepted. So we didn't lose the sight that it's going to be unsafe. We're going to save the dollar, but there are no benefits. I mean, there are some adverse effects to it. It was made sure that the benefit that we had with packaging A had the same benefit with packaging B. But packaging B, we saved $1. And how did we do it? We did it through FMEA, failure mode effective analysis. It was very helpful. Now, I cannot put all those examples here, but I'm just trying to share my practical life that we went through it. Now, here's the important thing. The FMEA has to be team approach. As I said earlier in the beginning, you cannot do FMEA in your cubbyhole. You cannot do FMEA in a silo. You have to have the team. The team approach is necessary. Responsible project leader leads the team. There has to be an owner. There has to be a leader. And that is also part of the process management goal. You have one owner per process. So in this process, you have one project leader. Now, here is the recommendation as far as the representatives are concerned. Design engineers, obviously practitioners, operators, supervisors, quality control, quality assurance, maintenance personnel, materials. I'm saying that these, I'm not saying in every single case you have to have, maybe you don't need a maintenance personnel when we were trying to do the encoder analysis or something. Materials management, testing engineers, key suppliers, but keep in mind why I have this in red. Consider having a non-expert in the group. The reason being, this non-expert can think of different ideas and things that come to his or her mind that you and I would not have even thought of, because our minds are trained as engineers, as operators, as supervisors, as quality control, and what have you. But this one non-expert in the group can shed very, very, very valuable information that you and I will scratch our heads. Oh, how come we didn't think of that? Now, mind you, this person can become like a fly on the wall too. So we need to deal with that. But that is what is recommended. Having said that, folks, this is my favorite. This is my favorite chart. Failure mode effective analysis is all about severity, detection and occurrence, RPN measurement. I think there's a little window there where it's my picture or Kevin's. That RPN measurement. So it's all about RPN measurement. The importance of measurements. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. Can't control it, you can't improve it. And that is our friend Cosby who said this, who was one of the three gurus on quality after World War II. Ladies and gentlemen, academia, scientists, PhDs, CEOs, founders, chief operating officers, whoever is present, I wish you all the very best in your future endeavors. And I learned something. Recently I learned something. As we educate ourselves, as the saying goes, the more you learn, the more you find out how little you know. And as we educate ourselves, we all have a responsibility. We have a responsibility to share our knowledge, to share our understanding with the rest of the world. We are not trying to impose. We are just going to share. So as you folks are highly educated, you're very valuable, you're contributing to the society in many meaningful ways. We all have a responsibility. That this responsibility should be sacred and should be kept with us. That we need to spread the knowledge, we need to help people out there, but don't restrict yourself to the valuable wealth of academics and the knowledge that you have. I once again wish you all the very best. And if you have some questions, I apologize for those screens that are not working out well. But I wish you all the best. And it has been my pleasure, my honor to provide my information and share with you in the form of workshop. Thank you and have a great day.
Thank you very much, Mr. Khalfan, for a great talking series.
My pleasure.
We will now open the floor to questions. If you have a question, you can just click on the hand icon and I will unmute your microphone. Alternatively, you can also send your questions in via the chat feature. So please go ahead if you have a question. Okay, the first question is from Harish. Firstly, Harish, thanks you for a comprehensive webinar. He has a query regarding revised severity.
Okay.
It reads as follows.
Let me go back to that slide so that maybe we can.
Okay.
Maybe this will help. I'm not sure, but yes. What's the question, please?
Okay. So the question is: I understand the severity is associated with the function, and if FMEA had identified high severity for a function, will the severity change after proposed action for that function, unless that function itself is removed from the system? He says his understanding is, with keeping function in place, the proposed action can help in reducing occurrence and detection. Is that correct?
Yes, of course. That's the whole idea of recommended actions. How can we? It's not only the severity, but what can be reduced. Example: severity can be reduced, the occurrence can be reduced, the detection can be reduced. So in the case of this hammer, the severity, when the machine fails, the machine stops, period. You can't process anything. Let's take this example. Severity is 5. Is fairly high. It's between 10 and 5, 10 and 1. However, with the improvement action, example, if the design improved locking device better, then the occurrence, instead of 7, it can come down to 4 if they took up on it. Or the detection can be even sooner, before there's a flag that comes in. Maybe the software will say, hey, don't send your document. The detection, it has detected that there's an error. So it's, yes, you're right, absolutely, the severity can go down, but severity, technically speaking, the failure dictates the severity. So the severity, it does not change, but it may change depending on what your action is. So maybe, let me take another example. So say there was a safety issue. It was pretty severe, like the one that I talked about here. The main PCB board, right? So you can see that now I'm at severity 1 to 10. The initial severity was 1 to 10, okay? Because it was going in smokes. So with the preventive measures that we took, we improved the soldering process, we improved by putting in a non-conducting material. Later on, instead of the non-conducting material, the entire base was zinc coated, that was non-conducting. So look at the severity. Where did it go from? It went from 10 to 1. It went from 10 to 1. Now that's a dramatic, because now with the action that was taken, it's not as severe. It's not going to go smoke. It's not going to go fail. So the severity obviously went down, and your end result was a RPN of 1 versus 60. Does that help?
Thanks, Harris. Does that answer your question? Or do you want to ask a follow-up? Yeah, and are there any more questions? Yes, Harris said it answers question. And you can see the answer. Any more questions? Okay, I have a sort of a general question, if I may ask it. How important is it for a team to regularly update the FMEA, and how would you determine the interval for updates?
If you don't mind, can you repeat it again, please?
Yeah, I'm just wondering how important is it for a team to regularly update their FMEA, and,
Okay.
and how would you determine the update intervals?
Hey, this is a very good question. Very good. I'm glad you asked. When the team sits on dealing with FMEA, depending on, again, we talk about the severity of the issue, the importance of the issue, what we are working at, you don't keep on updating. What you keep on updating, you work on it till you finish it, till you come to a conclusion. Now, you do have the time that you know who's going to do what, but you basically finish the item. It may take. This was a question asked to me way back as to how long does it take to complete a FMEA. Well, as soon as the team arrives at a conclusion that this is the action we are going to take. So based on 1, 2, 3, 4, 5, 6, the team, I'm just taking, the team decided to go with this action here, the one in the bottom here, right? Now, there were several things that we did. We came up with the conclusion that we are going to remove the short that is happening by putting a paper in it, and we are going to make sure the end of the line inspectors will check this. Now, that was done. We did the FMEA, right? And you monitor the results. But you don't keep on you keep on updating as far as the resolutions are concerned. You just focus on the problem that you have. You have selected the recommendation, and you keep on monitoring that. So when someone asks me how long will it take, it might take us 3 days for the team to come up to a conclusion. It might take 2 days. It might take 1 day. It might take 1 week. It might take 2 weeks. But the idea is that you want to select the action that is taken. Once, or the action that has been accepted by the team. Once you have that, then you don't meet as a FMEA team, but you keep on updating your reports, your progress, and what have you. And then you put it to bed.
Thanks. That really clarifies that. Any more questions? Anybody has? Okay. All right, Harish, you have one. I'm going to mute your microphone so you can go ahead. Go ahead, Harish.
Hello, Mr. Khalfan. Thank you for this comprehensive presentation.
My pleasure.
Yeah, I have another question regarding this FMEA template. Usually, what I have seen when somebody is building FMEA template, a block diagram, a system block diagram has been introduced before starting the FMEA. So, how important it is to have the block diagram?
I'm a big fan of block diagram. Block diagram, it's like a picture, and a picture speaks 1,000 words. When I do product life cycle workshops, seminars, or what have you, the block diagram brings the picture to your mind a lot more clearly than all this writing. The writing is good, it is necessary. But if you ask me how good it is, how important it is, in my books, it's one of the best things you can bring across to the audience as to what you're trying to identify and what you're trying to accomplish. That answer, or I didn't understand your question?
No, that's what I was trying to understand.
Yeah, I encourage, when we write procedures and processes and all that, I try to avoid writing, and I try to come up with one-page solution. I'll give you one quick example. So in the ISO standard, they talk about quality plan. Now you and I can write pages and pages of quality plan. But if you can explain, and I've done it, explain everything that you have in mind, what your quality plan is on one piece of paper, that is your challenge, and that's the best thing you can show the auditors or whoever you're trying to bring your point across. Here is our quality plan. The customer comes in, our design people, our marketing people accept it, then they go to the design team, the design team looks at it and says, we will need these many resources, we will talk to the OEM manufacturers, we will talk to supply chain. So you go through, and this is where I did say, that what happens on the sixth part of the symphony when you are in the design process. And then you have corrective action requests, you have management support. If you can demonstrate that on one piece of paper, you are a hero, because that saves everyone the time of reading pages and pages. Trust me, I've been auditing quite a number of companies, and when they throw all these procedures to me, the last company I went and audited, this company had nothing but writing, nothing. I spent 4 days going through their documentation, 4 days. There was not a single flowchart that could help me. So I encourage you to use block diagrams and flowcharts.
Okay, thank you. If I'm allowed, I have one more question.
Sure.
Go ahead.
Okay. So I've seen you have given some 4 different types of FMEA. So I was just wondering, because most of the time I've seen sometimes the process FMEA will have some linkage with the service FMEA, and the service FMEA will also have some link with the design FMEA. So will the RPN changes during this kind of association within the FMEA?
Mean changes from day to day? Or?
No, not day to day. The RPN will particular function, if it is associated within this FMEA, like with the process and the service, will the RPN change with the design FMEA RPN will change with the service FMEA RPN for the same function?
Oh, okay. So you're saying for the same function, service is doing something to improve their serviceability?
Yes.
They can be a same. So, example, let's take here, I'm not sure if I'll answer your question, but encoder hammer assembly, right?
Yes.
Now the design, what we went through here was the design. Now, if at the same time, example, the service engineers say, look, we don't have the time to wait for the design engineers to come up with a solution. We are going to take the bull by the horn. We are going to take the same failure and we will see how we can improve the serviceability of it, or how we can have better methods of troubleshooting and making it last longer. How? And I've been a service engineer too, and there are so many times that you come up with your ad hoc solutions to maybe not resolve the problem, but maybe the problem will not occur as many times. So if I understand you correctly, the design RPN can be different from service RPN because they have come up with their FMEA of addressing this issue. Right. But from the design point of view, they are designing so that the service people don't have a problem. Does that help, or I still didn't understand your question?
No, that's what I wanted to understand. So that means the service people can take design FMEA RPN as a baseline, and they can work on recommending the action for improvement.
Yes, and you'll be surprised. There are so many solutions that come from the real world that the design engineers see, the design engineers are enclosed in their four walls. The service engineers go and talk to the operators. They talk to the people who maintain that site. They talk to anyone that comes across that machine. So they have, and they work with the machines physically, day in and day out. They have many, many suggestions that can be, and I have many examples, but we don't have the time. But you'd be surprised that the service engineers are very, very helpful.
Thank you.
Okay, any more questions? Actually, I have one more, and
Sure.
I apologize in advance if I'm getting this wrong conceptually, right?
No, that's fine.
But my question has to do with how the RPN is calculated and potential limitations of that. Because it's being calculated through multiplication, it would seem to me that one disadvantage is that it makes it a little bit harder to sort of assess the relative risk. For example, like if you had an RPN number of say 5 and another one that's say 10, you can say that that's the one with 10 is twice as risky. That failure mode is twice as risky. Is that correct?
If
like
you strictly, go ahead.
Like you can say it's higher, it's clearly higher, but you can't say how much of a greater risk it is.
Oh, just by looking at the one number is not going to give you the insight to, the severity of the issue. But again, then you look at, I would say you look at individually to the severity, how you have scaled it, and the occurrence and the detection. And severity plays a key role. How severe is the problem? So if the severity is, I don't know, 5 or 10, whichever scale you're using, I'm not sure if I answered your question or I understood your question.
Yeah, it's just about sort of quantifying kind of how significant is that particular failure mode based on the RPN. By using the multiplication, you can clearly rank the sort of the failure mode that you should be attending to. But just looking at the way it's calculated, I'm sort of wondering, like, if you see one, like it's hard to quantify just how much more serious is one failure mode over another, like to quantify that based on the calculation.
Okay, so one suggestion I would have, again, keep in mind the business case also. Is the program manager going to fund you X amount of dollars based on what you came up with? So obviously there is cost calculation. So if you do this, as I said, the cost calculation, although that little gizmo was 5 cents, but there was a lot of testing done. So that has to be taken into account, that there is a lot of testing to be done. How much is that going to cost? How much is it going to cost to retrofit 15,000 machines, right? So all those things have to be taken into consideration, and that's the business case. Now, if I understand you correctly, I would ask that if you look at this slide, this may give you, see here, 1, 1, 1, 1, 1, no action. 1, 1, severity, 1, 1, 10, 10, no action. Then you got 10 severity, there's a concern. There is 10 severity again, and look, it's 100, it's concern, priority control. Now the RPN has gone higher. Now, you have to carefully take into consideration the RPN number constitutes what? Is the severity 1 in the 100 and these are 10 and 10? Or is it 10 and as you see over here? So based on what is happening with that given solution that you're trying to come up with. It's very difficult for me from here to say that no, you look at the severity if it is 10 or a 5 or what have you. So, depending on the issue that you're dealing with, the severity may be very low and the occurrence may be very high. The detection may be very high. Here, you've got severity it's not going to go in flames. It's not going to hurt anyone. The customer can keep on processing whatever it is, whatever they are processing, checks or credit card machines or whatever. But the occurrence happens quite a bit, and the detection is very easy to detect. It's easy to detect that your printing is not printing well. You look at the print and you say, oh yeah, it's not clear. It's okay, but it's not clear. And it happens, it happens more often. Then you look at the severity, but how severe is it? Is it impacting me that much that I need to go buy a new printer, that I need to call service, and say, the severity is not that bad. I can do with the printer. So you say low concern, or no action. So it all depends on what you're dealing with. That's, it does take practice. So it does take practice. It does take the team to be involved with. But once the team gets on the ball, then it starts making sense, and it is a very valuable tool.
Okay, thanks. So that makes it a lot clearer that you sort of have to have that holistic analysis once you identify problems.
Yes.
And also,
and taking, yes, and always keep in mind the business decision. You can come up with the best solution, but if your higher up doesn't take that because of whatever they have in mind as far as the business is concerned, then they can negate it. They can put you down.
Absolutely. But, any more questions? Chat. Okay, so I guess it's past 3 now. So we've now come to the end of our time, and I just want to once again thank Mr. Khalfan for a fantastic lecture and discussion and indeed series. This series I think will give our create trainees a really thorough grounding in QMS. And I would encourage everyone who missed some of the earlier talks to go ahead and look back at the recordings, which will be posted on Learn as well as our YouTube channel. And you might also want to revisit this one from time to time if you want a refresher in FMEA. So thank you all for attending. Thanks, Mr. Khalfan, and please enjoy the rest of your week, everyone, and stay safe.
Thank you all once again, and all the best in your future.
Bye-bye, everyone.
Yeah, bye-bye. All right. Thank you, Kenrick. Appreciate you taking charge of it and running it through and holding it together. Appreciate it. I'm sure.
No, thank you. I mean, it's been fantastic. It's been wonderful working with you. I really appreciate how much work you put into this, how much care you put into the lectures, and for always being accommodating with everything. So thank you very much. I really appreciate it.
Thank you. My pleasure working with you too, and I'm sure it's a small world. We'll meet somewhere and we'll connect somewhere.
Absolutely. So yeah, so hopefully you can get through. I know you're very busy nowadays, so hopefully you can get through all your tasks quickly and efficiently and enjoy some of the good spring weather.
Yeah, you too. Yeah, let's be in touch once in a while, ping each other and see where we are, and maybe when things are good, we meet for coffee or lunch and No.
Absolutely. That sounds great. That sounds great.
Great. Okay. I will just